Users of CBRNE detection equipment are typically wearing heavy protective gear and face various environmental conditions that challenge their ability to view and manipulate the controls of their detection devices. The new HazMatID overcomes these challenges and features an interface that has a high visibility in direct sunlight, large keypad controls, an intuitive workflow, and a modern look and feel that is consistent with your everyday electronic computing devices.
Smiths Detection's new HazMatID is operated using a large keypad controller with keys that can be lit individually to guide the user through the software operations. On the top right of the display screens, we show the status of the system, including remaining battery life and wireless signal level. From the home screen, the user can select from 4 options. Settings, which is accessed by selecting the star key, allows the user to set the date and time, turn alert tones on and off, and perform other system maintenance functions. Throughout the software, the function of the star key changes and typically represents some type of special operation. Using the up and down arrow keys, the operator can select the remaining options. System Check will allow the user to run a standard verification sample to verify and log system performance. Results will allow the user to review previous results collected on the device and export those results to a command center or physically connected memory device. All System Check results are also included in the previous result menus and can be exported for evidentiary purposes. By selecting Identify, the user will be guided through the standard operation of the device, where unknown chemical substances will be identified via comparison with onboard databases of FTIR spectra. After selecting Identify, the software shows the user the status of the background acquisition process, during which the signal is being baselined with no sample present on the sensor. During this acquisition, specific system parameters are being collected, such as the internal temperature and signal-to-noise levels, and these parameters get fed into the library search process to optimize the chemical identification results. Once the baseline reading is complete, the user sees a signal quality meter that will increase as the sample is loaded onto the Diamond ATR sensor. Initially, this meter will read 0, be color-coded in red, and will fill only a slight portion of the screen. As the sample contacts the sensor, the reading will change to 1, turn yellow, and fill half of the screen. Finally, when sample loading is complete, the meter reads 2, lights green, and fills the whole width of the screen. The same red and green indications are provided when the system is switched into touch-to-sample mode with the second Diamond interface. From this screen, the user also has the option to select the star key to preview the infrared spectrum in real time. Finally, the user selects the right arrow key to initiate the data collection process. The analysis time on this device is fixed by the user and will never take an unexpectedly long time. This is in contrast to the approach taken in other handheld FTIR devices, where the analysis time can take tens of minutes or even hours, depending on the user's level of expertise. The new HazMatID is designed such that users of all experience levels can always get accurate results in less than 1 minute. Once the data acquisition is complete, the onboard spectral databases are searched using the same proven algorithms used with the HazMatID 360, but optimized for the high-speed processor of this new device. Typical library search speeds are 10 times faster than they are on the HazMatID 360. If the user elects to screen for a targeted list of high-priority chemicals from the system database, they will quickly see those high-priority matches appear on screen. These priority alerts may include chemical warfare agents, narcotics, explosives, or toxic industrial chemicals. The appearance of an alert tells the user that the observed signal is consistent with the spectral features of one or more priority threats and serves as a fast, presumptive identification of chemicals of high interest. In the hypothetical case shown here, 3 priority alerts were produced. Each alert is shown with a graphical icon representing its class, with the class also printed on the right-hand side of the screen. The full chemical name is also shown along with a 5-segment scale depicting the level that each target may contribute to the overall signal. In a case where 5 bars appear, it is possible that the material was present in the sample in a nearly pure form and would likely be the only alert shown on the screen. A lower number of bars would indicate that the sample is probably a mixture, perhaps of chemical agents mixed with contaminants, homemade explosives, or narcotics mixed with cutting agents. The key benefit here is that the critical information, the possible presence of the most important chemical threats, is communicated to the user as quickly and simply as possible without having to carry out a lengthy analysis process. Immediately after receiving a priority alert, a user can export the result file wirelessly to a command center by selecting the star key. The file will arrive at the command center within a few seconds, and the operator can then elect to run a full library search or select the Home button to exit. The user can select Library Search to see the results from the roughly 10,000 Spectrum database installed on the device. This database can also include user-defined libraries generated previously by users of the HazMatID and HazMatID 360 products. In most cases, the library search results will be seen instantly after selecting the right arrow key, because the device automatically runs the library search in the background while the user is viewing the priority alert results. In the example shown here, a mixture of 3 components was identified, consisting of a homemade explosive. Shown are the chemical names, the CAS registry numbers, and a text indicator of the hazard class of each material. The chemicals identified are HMTD, hydrogen peroxide, and hexamine, with HMTD tagged as an explosive, hydrogen peroxide tagged as an oxidizer, and hexamine tagged as a fuel. The circular wheels on the left-hand side of the screen report the estimated relative contributions of each mixture component to the overall spectrum. In this case, the mixture is reported as 3 parts HMTD, 1 part hydrogen peroxide, and 1 part hexamine. From here, the user can again use the star key to export the results wirelessly to a command center, and can select the right arrow key to view the sample and library spectra that were recorded, or select the Home key to exit the results screen.
The new HazMatID is easy to use, intuitive, and is a powerful assessment tool for the identification of unknown chemical hazards. It provides the responder with the critical information they need to see on scene and enables a wireless link to their incident command center or other line of authority to streamline critical decision making. We've shown you how an unknown substance can be measured, identified, and the results transferred wirelessly to a command center in just 3 clicks of a single button. "Don't turn us into buttonologists" is a statement that we've heard from first responders. We've translated that requirement into the most user-friendly FTIR system ever created.